Okay, in this section, I'm going to lay out for you the basic fallacy that we're committing when we infer that the occurrence of unlikely events is evidence of some kind of non-random force or influence. Later on, I'm going to dissect this further and elaborate on the reasoning, but here I think it'll be helpful to see the simplified, high-level version of the argument. We start with a conditional claim that if we judge an event to be highly unlikely, highly improbable, then we should not expect to see it. We do judge an event to be highly unlikely, therefore we should not expect to see it. But we do see this event. We read about it in the newspaper, or our friends tell us about it, or maybe we experience it directly. It happens to us. What do we infer? We infer that maybe we were wrong about this event. Maybe this event is not highly unlikely. But this inference is now in conflict with our earlier judgment that the event really was unlikely. So how do we reconcile this conflict? We infer that maybe there is some mysterious causal power that is intervening, that explains why we see this event that otherwise we should not see. What kind of causal power? Maybe it's a miracle. Maybe it's fate. Maybe it's evidence of psychic powers or supernatural forces. Maybe, quote unquote, there are no coincidences. Have you ever heard someone say that? It's destiny. It's providence. It's the universe trying to tell us something important if we can only decipher its meaning. So what I'm calling the basic fallacy involving our reasoning about coincidences is this move from observing an unlikely event to the conclusion that some mysterious causal power is intervening to bring about this event. All right, so where exactly is the fault in this argument? There are a couple places you could point to, but I'm going to focus on the first premise. If an event E is highly unlikely, then we shouldn't expect to see it. Now there's something right about this, and we're going to elaborate on what's right about it shortly. But first let's schematize this a bit. Let's call the condition that an event is highly unlikely U. And let's call the statement about not expecting to see it R for rare. So this claim is a conditional statement that says that if an event is highly unlikely, in a probabilistic sense, then it is rare, where rare means that we should be very surprised to actually observe it. Now, if we just left it like this, then when we observe events like this, we would be entitled to infer that the event is not, in fact, highly unlikely. And this is where we get into trouble, since our intuitive understanding of the event is that in the absence of mysterious interventions, it really is a probabilistically unlikely event. So where's the problem? The problem is that this conditional claim only holds if we make a bunch of background assumptions. A more accurate description of the inference from unlikely to rare requires that a set of additional assumptions also be true. And it is only when these assumptions hold that we can legitimately infer that the event in question is rare, in the sense that it would be very surprising to actually observe it. Now, this simple expression now gives us a strategy for thinking about what's going on when we observe these so-called rare events. If we do observe such an event, then this is actually evidence that the event, in fact, is not rare. And if it's not rare, then we can infer that one or more of our background assumptions is probably false. If we can identify the faulty assumption, then we can reconcile our judgment that the event is probabilistically unlikely with the fact that we observed it happening, without having to infer the presence of mysterious forces that are conspiring to bring about the event. The basic logic looks like this. If we actually observe this event, then we assume that the event is not, in fact, rare. But this points to a problem with our assumptions about the event. They can't all be correct. Maybe we're wrong about the initial judgment that the event is probabilistically unlikely. But assuming that we're not wrong about this, then we need to take a closer look at the background assumptions, because the mistake is probably lurking somewhere in there. By the way, this bit of logic you're seeing is really fundamental to any diagnostic process. Your car mechanic uses it, your doctor uses it, you use it. It's an argument pattern that involves understanding all the different ways that an observable event can come about, and then eliminating possible causes of the event until you've identified the actual cause. Now, the next question is, what are these background assumptions I keep talking about? Well, there are a handful of important ones, and anyone familiar with probability theory or statistical reasoning will recognize them. I'm tempted to make up names for them myself, but David Hand has written a new book called The Improbability Principle that covers a lot of this ground in a very readable and engaging way. So I think I'll take the opportunity to plug his book and just borrow some of his language. He identifies 5 principles, which he calls laws, but the labels aren't important. What's important is that packed inside each principle is an assumption that can have a big impact on the likelihood of observing a so-called unlikely event. I'm just going to run through them very quickly here, and then we'll break things down a bit and look at some examples. The first law he calls the law of inevitability. This law says that when you've listed all the possible outcomes of a random event, at least one of the outcomes has to occur. It's inevitable. If you sold 1 million lottery tickets and one of them is the winning ticket, then it's inevitable that someone is going to win. The second law he calls the law of truly large numbers. This says that even if the probability of an event is very small, if you're given enough trials, enough opportunities for the event to occur, then you shouldn't be surprised if the event occurs. When the number of trials becomes truly large in hand sense, then even seemingly miraculous coincidences like winning the lottery twice become statistically likely. The third law he calls the law of selection. This law says that if you're allowed to characterize an event after it has occurred, then you can make the probability of that event very high, especially when you conjoin that with a large number of trials. This is the kind of thing you observe when you discover, for example, that 2 people at the same party have the same birthday, or any kind of data mining experiment where you look for patterns in a large data set. The fourth law he calls the law of the probability lever. This isn't the most descriptive name, but what it refers to is the fact that a coincidence may be judged very unlikely if you think that 2 events are statistically independent of one another. But you might be mistaken about that. The events may in fact be correlated, which could dramatically increase the likelihood of observing them together. Statistical correlations, or probabilistically dependent events, can radically change the likelihood of observing events together. The fifth law on David Hand's list he calls the law of near enough. This law refers to the fact that we often judge 2 events to be identical even when they're not identical. They're just similar. They're near enough to count as the same event. For example, if a psychic tells me that I work as a teacher, I might think, wow, she got that right. But teacher is a broad category that can include elementary teacher, high school teacher, college teacher, music teacher, martial arts instructor, business trainer, homeschooling parent, and so on. Now the odds of getting a hit with this statement are higher than we might think, since all of these are near enough to count as the same event. That's the kind of example that this law tries to describe. Now, the upshot is that all of these principles describe assumptions that, if they're in play, can dramatically increase the probability of observing what at first glance appears to be a very unlikely event. So, in terms of the logic of the fallacy that we've been describing, if you observe an event that you judge to be very unlikely, then before you go claiming it's a miracle, you should pause to consider whether there are factors at work that would make this event more likely to occur than you might otherwise judge. In the next few videos, I'm going to look at some well-known cases that illustrate these principles in a little more detail. Before I move away from this lovely picture of David Hand's book, I just want to reiterate that there's nothing special about these labels. David Hand does an excellent job showing how they apply in a variety of cases, but they're really just principles that are part of the package of concepts you learn to use when you do statistical reasoning. I recommend David's book to anyone interested in following up on these ideas, but nothing we do from here on is going to require this language.